All right, in this video, we're going to continue with our Unit 2 review. This is part 2. It says if a parallelogram WBMP is reflected across the y-axis and then translated 4 units down to become a parallelogram W prime, B prime, M prime, P prime, what will the coordinates of M prime be? All right, so let's figure out what are the coordinates of M. So looks like negative, here's the origin, so -3 and then -6. So let's start with that. So M is at -3, -6. When we reflect it over the y-axis, and this point is going to be 1, 2, 3 units to the y-axis, so we're going to move it 1, 2, 3 units. This is where M prime is going to be. And so our first move for M prime will be 3, -6. And then we're going to move this down 4 units. Down 4 units is going to affect just the y value. So M double prime will be 3, and then -6 minus 4 is -10. And so that's F. In 17, we have quadrilateral PSTU. With these coordinates, rotates 270 counterclockwise. So counterclockwise, this is one of those that I just have to commit to memory. It is y -x. 270 is y -x. So what I've done is go ahead and I've labeled each of my points, and I just have to do this to them. So you can see that the first coordinate is the y. And so for P, I'm going to have the y value first, which is 5, and then the opposite of x. So my x value is -3. The opposite of -3 is +3. And so there's my first point. We're going to do the same thing with S, T, and U now. So I want the y value first, and then the -x. The y value, -x, y value, -x. In number 18, we have segment CF graphed on the coordinate plane where C is located at -12, 7. So it's way over here off the grid. F is at 3, -3. So I've got these plotted already. And it says, what are the coordinates of the midpoint? And when we're finding the midpoint, we're finding the average of the x's and the average of the y's. And so I'm going to go ahead and label my points again every time. And trust me, I've been doing math a long time and I still do that. So let's average the x's. -12 plus 3 divided by 2 gives you -9/2, which is -4.5 as a decimal. If I average the y's, I've got 7 plus -3/2. That gives you 4/2, which is 2. So this is -4.5, 2. Point B, what are the coordinates of a point located a third the distance C to F? Okay, so we need to find the distance, the x distance and then the y distance, multiply it by that ratio, by that fraction, and then add it to the first coordinate. So it sounds like a lot, but it's really not too bad. All right, so I want the distance, the x distance from C to F. So let's take the x from the F is 3 minus the x from the C is -12. All right, so when we subtract those, that gives you the absolute value of 15, which is 15. So we know that the distance in the x direction is 15 units. If I want a third of 15, you're going to multiply straight across, which gives you 15/3 or 5 units. 5 units from C. So if the C coordinate is -12, add 5, that means it's going to be -7. All right, let's do the same thing for the x coordinates. I'm going to do this one in purple. So I need the distance from C to x in the y direction. All right, so the y2 is -3 minus the y1 is 7. That gives us a distance of absolute value of -10, which is 10. 1/3 times 10/1 is 10/3. I'm going to leave it as a fraction now. And so starting with the y distance, that one is 7. And in this case, we're going to be going down. We're going to be subtracting 7, because if we were to connect these two, C and F, we know that the somewhere along this line, I don't know, maybe right in here or so. Actually, we can we can actually pinpoint this a little bit better because we know it's going to be at an x value of -7. We just have to figure out, well, how accurate is my line, first of all. I'm going to go ahead and clean that up just a bit. And let's see, I was guessing that C is out here. So it's hard drawing a straight line. We know the distance is at -7. What is the corresponding y value? And then now you can kind of see, if I were to cut this from C to F into thirds, maybe somewhere right in there, we can see we've got 1/3 here, 1/3, and 1/3 make one whole. And so we can see we're in the right ballpark. We're doing this right. But we've got to figure out what that value is. All right, so I'm going to subtract 10/3. Now, you may have forgotten how to subtract fractions. So put a 1 under the 7. We need a common denominator, and that's going to be 3. And we find that by multiplying the 1 and the 3. And so this first fraction, I'm going to need to multiply by 3/3. This gives you 21/3 minus 10/3, which is 11/3, which is, let's see, 3 goes into 11 3 times and 2/3. So my y value is 3 2/3. Let's see if that matches. Let's see how well I graphed. Looks like 1, 2, 3. Hey, pretty good. I was pretty good. So my y value, anyway, I get excited. 3 2/3. That is the coordinate of a point, 1/3 the distance from C to F. All right, number 19, which of the following letters has reflectional symmetry? And it doesn't say over which axis. So any of these that we can either draw a vertical line and it reflects. This one actually reflects both. Hey, reflects. Wow, a bunch of these. Reflects. This one also. All of these. So the only ones that don't are the F and the G. It didn't say over which axis. So that just means if you could fold it on itself somehow, either vertically or horizontally, all of those. Nice. All right, 20. Which of the following have rotational symmetry? So I want to rotate this. We can rotate 90 degrees. And let me just remind you what that looks like. We're going to rotate it 90 degrees, 180 degrees, 270 degrees. Okay? So if I can rotate this guy, A won't be A on its side, A upside down. Let's see, that's not going to rotate. B on its side, B upside down. So some of these are, let's see, D on its side, D. I will rotate because I, and then I, and then I. It's going to land on itself. And same with H. I don't think any of the other ones can think of it. Here's K on its side, and then K, that's not rotational. M on its side, and then M looks like a W, but that's not the same letter. Okay, I think those are the only ones. 21, what is the equation of line parallel? Parallel means same slope. This just happens to be in slope-intercept, so I can see my slope is 2. So my slope is 2, and I've got an x1, y1, so y2 minus y1 is equal to m. x2 minus x1, let's see. I don't know why I'm putting 2's. Forgive me. I'm always used to my second. It's just y minus y1 is equal to m x minus x1. That's why I was like, huh? All right, here's my favorite form. It's called point slope. If you go to calculus, this is exactly how you'd leave your answer. However, we're not in calculus. Let's go ahead and distribute and combine our like terms. Distribute the 2, so that's 2x minus 2. Go ahead and add the 5, and we get 2x plus 3. Those are equivalent, worthy of the same amount of points. 22, find the distance. Okay, I wrote down your distance formula already. Just to speed things up between these 2 points. So I'm going to first thing, label my points, x1, y1, x2, y2. And it doesn't really matter which one you pick for the first and first x, first y, or second x, second y, as long as they're grouped together. So distance is equal to x2, and I said that was 6 minus x1 squared plus y2 minus y1 squared. Okay, so that's 5 squared is 25. And this is going to be negative 4 squared is 16, and that's the square root of 41. And I don't know what that is, so I'll leave it just like that. 23, find the slope of a line perpendicular to this. Well, you can't identify your slope until it's in slope-intercept form, so let's go ahead and solve for the y. We're going to get the y term by itself, so I'm going to move the 6x to the other side, and then divide everything by the negative 5. Keeping everything balanced. Here is my slope. It's going to be a double negative, so this is a 6/5. Perpendicular is opposite reciprocal. Got to flip it and negate it. 24, find the slope of a line parallel. Okay, let's solve for this y. 4y is equal to, move your 3x to the other side. Divide everything by 4. If I want a parallel slope, I'm looking for the same slope. Don't need to reduce or anything. Done. Negative 3/4. 25, find the distance between these 2 points. Okay, x1, y1, x2, y2. Plug it in. And x2, 5 minus negative 3 squared, negative 2 minus 6 squared. So that's 8 squared is 64. And hey, negative 8 squared is 64, square root of 128. I used a calculator earlier, and that's 11.3 to the nearest tenth. Tenth is 1 decimal place. 26, AB has endpoints given. Find the point that is 3/4 the distance from A to B. Okay, we've done this before. We need to find the distance from A to B in the x direction and the distance from A to B in the y direction. And so this is my x1, y1, x2, y2. Let's find the distance for the x's. So 2 minus 6, which is going to be absolute value of negative 4, which is 4. And we want to be 3/4 of the distance. So 3/4 times 4 over 1 is 12 over 4, which is 3. So if I think about this, I'm starting from A. I've got to take the x-coordinate of the A, and if I just think about a little sketch real quick, 2, 4, it's right there, 3, 4, 5, 6, 7. Okay, so I'm going to be, here's my little line segment, and here's my A, here's my B. I know I'm going to be adding to the A 3 to the x coordinate of the A, so I know that's going to be 5. Let's do the same thing for the Y's. All right, so let's see, 4 minus 7 is equal to the absolute value of negative 3, which is 3. And 3 over 4 times 3 over 1 is 9 over 4. That's what I'm going to add to the y value. So 4 plus 9 over 4. Common denominator is 4. I need to multiply this first fraction by 4 over 4. That gives me 16 over 4 plus 9 over 4, which is 25 over 4. And let's see, 4 goes into 25 6 times, and a 6 1/4. So my y value would be 6 1/4. And let's see, on my quick little sketch over here, does it make sense? All right, so 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6 1/4. And yeah, if we look at this segment here, if I were to cut this into fourths, that guy landed right there, which is looking good. All right, 27, write the equation of a line perpendicular. Perpendicular, opposite reciprocal. Here's the slope. It's already in slope-intercept form. So I'm going to flip it and negate it. So my slope, my perpendicular, and this upside down t represents perpendicular, is going to be positive 2. And here's an x1, y1. So again, use my favorite equation, y minus y1 is equal to mx minus x1. So that's a double negative. That makes it plus. Calculus, here you go. Sorry, geometry. We got to distribute and combine our like terms. 2x plus 6, add 7, y is equal to 2x plus 13, and that one's done. All right, last problem. Reflect the point negative 5, 4, and I just drew myself because I'm a visual learner. I got to see what it looks like. If I'm going to reflect it over the x-axis, here's the rules. And guys, write the rules. It's so much easier if you have the rules written down and you label your points, then you just follow the rules. It's telling you to negate the x, keep the y. So this would be 5, 4. Let's just see. Did I do that right? Oh, I think I did the wrong formula. If I'm going to reflect over the, and it's okay to be wrong as long as you catch your mistakes. This is my x-axis. Did I write it down wrong? See, it's going to be down here. I'm going to keep the x, change the y. Oops, wrong formula. My bad. That happens. Happens once. Okay, so we're going to keep the x, change the y. That means I was working really fast, trying to get through this. Okay, negate the x, keep the y is over the y-axis. Oopsie. That's okay. There's my reflected point. So I know it's going to be a -5, and the 4 becomes a negative. I keep the x, change the y. Now, go back to your original point, reflect over the y-axis. All right, so I'm going to reflect over this guy. Do you see how my x is now changed? So this guy is going to be, change the x, is going to be 5, and keep the y, 5, 4. All right, for C, we're going to reflect over the line y equals x. All right, go back to your first point, this guy right here, reflected over this guy. We switch the x and the y. So it's going to be 4, -5. And let's just see if that makes sense. 1, 2, 3, 4. 1, 2, 3, 4, 5. Hey, there's the reflection over the line y equals x. And the last one over the origin. This is where you change the signs on both of them. So this is going to give you 5, -4. And let's just see what that looks like. 1, 2, 3, 4, 5. -4 would be right here. And that's over the origin.